Cool, let's have a look at MET 2011, question 2. So, suppose that x satisfies the equation x cubed equals to 2x plus 1. Show that x to the 4 is x plus 2x squared. I suppose that should be no problem, right? And x to the 5 is 2 plus 4x plus x squared. Okay, so I suppose this is quite obvious, right? Just multiply the whole thing by x, then it's fine. How about x to the 5 though? So let's multiply this one by another x. So what have I got? X to the 5 equals what? Equals x squared plus 2x cubed. Fine. Now, what do we know x cubed is? X cubed is 2x plus 1. So I have x to the 5 equals to x squared plus 2x plus 1. Lovely. Then I get the desired result, right? X squared plus 4x plus 2, as required. Sweet. Okay. Part 2 then. So I want to show that ak plus 1 equals to ck, bk plus 1 equals to ak plus 2ck, and ck plus 1 equals to bk. Okay, this is not the hardest thing on earth, I suppose. So, we know x to the k is this. Fine. X to the k is ak plus bkx plus ckx squared. Fine. Now, I want k plus 1, right? I want the k plus 1 version of this. So let's multiply the whole thing by x. So now I could obtain x to the k plus 1 equals to ak of x plus bk of x squared plus ck of x cubed. And what could I write x cubed as? 2x plus 1, right? So let me group the terms a bit. So bk x squared plus ak plus 2ck, is it? Of x plus c of k, right? Is it c of k itself? Yes. Good. Okay, so now we compare, right? So ak becomes k plus 1, I suppose. Sorry about that. No. That's right. Yeah, that's k. Yeah. Okay. So I should be comparing the k plus 1 version, right? So a of k plus 1 is c of k by comparing constants. Yeah. So that's good. How about b? B of k plus 1 is ak plus 2ck. That's also good. And lastly, c of k plus 1 is b of k. Okay. So all done. Sweet. Okay, let's move on to part 3. Let d of k equal to that. Show that dk plus 1 equals to minus d of k. Interesting. Well, you just have to sub in what you got in question 2, I think. I think that's what they want, right? Just sub in, like b of k, sub it there. You know, c of k, sub it there, and then, you know, just sub in appropriately, right? Sub in appropriately. Then you could show this. I think this is trivial. I'm not going to do it. Okay, and hence that this is true. Okay, let me write this in an alternative form. What if I do ak plus ck minus bk equals to minus 1 to 2k? Then it makes it apparent that this thing is just actually d of k, right? And you know that d of k is just flipping around. It's the positive and minus, positive and negative, you know, flipping around, essentially. Okay, good. So let's try to find d of 1. What is d of 1? D of 1 is that, no, it doesn't exist. Okay, I suppose, oh yeah, it does exist, right? D of 1 is just, what? So, what is it? For every, well, let's, what's d of 1? Is a of 1 plus c of 1 minus b of 1. Okay, what is that even, what even is this? Well, I suppose it's just x itself, right? So, equals to 0, 0, 1. Okay, yeah. Okay, I had a bit of a short circuit there. Okay, so 0 plus 0 minus 1. So d1 is minus 1. What does that tell you about d2? Well, d2 is 1 then, right? Because by what we just showed. And d3 is minus 1, d4 is 1, and so on. Okay, so that's why the minus 1 to the k is correct, right? When k is odd, then d of k is minus 1. When k is even, then d of k is 1. So that's all good. Cool. Okay, last part. F of k equals to ak plus 1 plus c of k plus 1. Show that okay. So where should we start? Let's start from the left-hand side, shall we? So I have f of k plus 2 on the right-hand side. So I think a good thing to do might be try to increase the index, right? It might be sensible to try to increase the index. Okay, so let's actually substitute what they defined first. Plus c of k plus 1 plus a of k plus 2 plus c of k plus 2 equals to well, okay, we're proving things, right? So we don't write the equality yet. Just go left-hand side. Okay, let's try to increase the index, right? Because I want k plus 2 here. So essentially, use these equations up here, but in the reverse direction. Okay, but in the reverse direction. That's really important. Okay, so let's try that. So what have I got? So this is what? What if I write this as how do I do this? I add one more ck plus 1 and I subtract the ck plus 1 from it. This is fine, right? Okay, then what is this? This is just b of k plus 2. And what is this? This is just a of k plus 2. Plus c of k plus 2. All good, yeah? And this equals to how many? What is this? So am I doing something wrong? No, I'm not. Okay, so what is b of k plus 2 now? Okay, oh no, I am doing something wrong. This should cancel, right? Yeah, okay. A of k plus 2 plus c k plus 2. Okay, I was ahead of myself. These things cancel. All right, sweet. Okay, now what could we do? B of k plus 2 is what? B of k plus 2 is c of k plus 3. All right, and what is c of k plus 2? That's a of k plus 3. Good. And what is this? This is exactly the definition of f of k plus 2. Lovely. Okay, so I think the main technique is to spot this thing, which I suppose is manageable, right? Not the hardest thing to spot, hopefully. Good. Okay, quite a lovely question. Not the hardest out of the 5 questions, I suppose. So, okay, there you go.